Welcome. This presentation is New Ways of Learning Using Games in the 21st Century Classroom. My name is Jacob Enfield. I have a previous life in which I was a middle school and high school teacher. I taught math and computer science courses such as game development and AP computer science, Java, ActionScript, Flash, all kinds of stuff back in the day. I also worked briefly as an educational game developer for Edutainment Systems LLC, and so I have a little bit of industry experience in the game industry, in the serious game industry. I also was a university faculty at another university where I was in the Cinema and Television Arts Department doing digital media production. Now, though, I am at George Mason University, Computer Game Design, and I am also part of the Virginia Serious Game Institute, the VSGI, where we do research. And the courses I teach are mostly coding programming courses for game development. I also have started up my own little side company, Second Job Studios LLC, that focuses on educational games. So the presentation that we're going to do today is focused on kind of two primary things that I'm interested in, which is learning through gameplay and learning through real-world application. So with learning through gameplay, we're going to start off with just what is this promise of game-based learning that I've heard for many, many years, and is it true? And then we'll talk about some examples, including a Paizo math game, a murder mystery game, and an escape room game. And then I'll give you one example of learning through real-world application, which is game development, learning math through game development. So let's start with the promise of game-based learning. First, there's cognitive and learning benefits, right? And here's some of them listed. These are all the things that, if you look into the research and the theory of game-based learning, you're going to say, hey, these are the things that align well and promote learning. But there's also another area of motivation and engagement, just getting people motivated and interested in what they're learning. I really like number 3 here, the safe failure, that you know when you're playing a game and you fail, you don't feel bad about it. There's no problem with that. You're expected to fail and to try again and fail and try again, which is kind of different than our regular traditional classrooms. Social emotional benefits are listed as promises of game-based learning. I like number 4 there, resilience and perseverance. So, gamers can lose over and over and over and over, and they just keep working at it and trying, and that's what we want to see in our students. So, skill development, of course. You're going to be developing skills as you go along, but what kind of skills will you develop? There are things that are applicable outside of games. Let's go on to instructional and assessment advantages. You see some examples there. And these are things that a lot of digital media have, like number 3 there, differentiated learning. A lot of digital media is able to kind of adapt for the particular user and what their current inputs are. And real-world application. And there I'll just kind of focus on number 1, the simulation of authentic environments. You're put into a world, and that is a simulated world, but it is a real world situation potentially, and you're able to apply your content within that real world. So again, these are all just kind of examples of the promise of game-based learning. By no means is this an exhaustive list. So what's better? Books, are they better for learning? Radio, just hearing the message, or video, seeing and hearing it. Computers are better for learning. I remember when that was the big thing. I was younger, but I remember when computers came into the classroom. Are games better for learning? And I've been hearing that for a long time now. Is VR better for hearing? So in 2017, VR kind of blew up, and being immersed in a virtual world was the next new thing. Now it's AI. Is that better for learning? Or whatever next amazing new technology. Is that better for learning? So these are all interesting questions that you can debate. But I'm going to kind of fall back on an older media debate that's between Clark and Kozma, who basically discussed this. Clark was saying it doesn't matter what media you're using, it's the instructional methods that are used. And he published that in '83 and had a lot of research backing that up. So he just saw the media as the vehicle for delivering the message or the content, and it didn't really matter how you delivered the message as long as the message got across. But Kozma disagreed 10 years later, decided that the affordances of a technology change how you're able to teach and what your learning methodology might be, or your teaching methodology might be. And so that debate always kind of is in the back of my mind when these kind of questions come up. And by no means do I think games are the solution, the tool that fixes everything. They do offer some affordances that other technologies might not, but I would see value in all media and really focus on the instructional methods being used, instructional design. So what makes a good serious game then, if we're talking about good instructional design, grounded in learning theory? Well, that's where my actual PhD was, and so I can go on and on about this all day, about what is good learning, good instruction, good design versus bad, but that's really what I feel should guide the design and development of a game. That's what's going to make a game good or not so good. So here are some examples, Merrill's 5 principles of instruction. I'm not going to go through all of these, but a lot of instructional design models are used in this field to kind of guide how instruction should be delivered. So in this case, it's problem-centered, there's an activation, there's demonstration, and this is a very brief overview of it, but you can see there's something guiding that design. There's also Gagnier's 9 events, and it's similar. It's saying, hey, what are these 9 things that need to occur for learning to happen at its best? My favorite, what I wrote my PhD over, was how to use the 4CID model to improve the design of the Diffusion of Innovations game that I was working with at the time. And this one's pretty complex. I'm not going to try to discuss it here, but you can see that all of these models are ways that learning should be designed, and there are some that are more descriptive and there are some that are more prescriptive of how should you do it. So for instance, 4CID model has another 10 steps to complex learning that tells you how to do it, how to achieve this. What else makes a good serious game? Rapid prototyping and iterative design. This is a big one, I think, in really any art form, especially in video production and film and television and games, is that if you make something and give it to the people, it's not going to be very good. You really need to be making something and having people try it and make and improve it and having people try it in a very iterative process. So you're basically designing, you're developing, you're testing, and just over and over and over to make sure that there's a good response to the game, that it is effective for learning, it is effective for whatever your primary goal is, that it's engaging, entertaining, there's no usability issues. And that is super critical that I think a lot of serious game designers overlook, mostly because serious game design budgets are much smaller than AAA big game budgets. And then you can kind of tie this back into instructional design a little bit, the famous ADDIE model, which is analysis, design, development, implementation, and evaluation. This process is not just for learning purposes, it's oftentimes solving some problem that's going on and designing a solution for it, but it's often applied to learning, and it is iterative, something you do over and over and over until you have the solution that is effective. And then one more thing that makes a good serious game is integrated gameplay. There's, again, a lot of these, just like we saw in the promise of a good game, but integrated gameplay is one that I really focus on a lot. And here's a good example. On the left here, we see a picture of a little game character going up to a locked door. Well, how can I get through that locked door? Well, answer this multiple choice question. If you get it right, you get to go through the locked door. That is not integrated gameplay. That is putting an assessment, a quiz question into a game and saying, hey, answer this question. It could be on any content and it has nothing to do with what's going on in the game. And you say, hey, answer this question correctly, and the door opens. And students see right through that. They understand that this is not really a game. This is just a quiz, an assessment. And so it's not, I don't view that as really a serious game as much as kind of gamification maybe. Besides the example I just gave, might as well go ahead and go through the question. What is typically good design for serious games? What do you think the answer is here? Well, A is not the right answer here. As we just discussed, multiple choice questions that are used for progression are typically not the way you want to design a serious game. Also, B is not correct because a single repeatable path to victory exists. And in most good serious game design, you're going to have many ways to get to victory. There's not always one solution. The next one that's wrong is D. Follow the tell, show, do learning principle, which many teachers do in class. They tell you how to do something or how something works or the concept that's being taught. They might show you, if they're, say, a math problem, they might demonstrate how to do it correctly. And then they have the students do it. And that's a great principle to follow in classroom instruction. But for a game, you want the player to do a lot quicker. You don't want them, sitting back and watching an instructional video, right? They are playing a game to be active, to be engaged, and maybe have more discovery learning, and the just-in-time information is kind of sprinkled through when it's needed. So the correct answer is learning objectives are embedded within the game's design, narrative, and mechanics. And that means that the gameplay itself and the game world all are tied in with what you're learning. They're not just kind of layered over it. And in the next little part of the presentation, I'm going to be giving you an example of where the game mechanics really are tied into the learning objectives. And that game exists, the one we're going to talk about, exists within this Piezomath platform. So this is our first example of learning through gameplay. This suite of games is my little side project, the one that I just started my LLC with. All right, this is the platform for Piezomath that we're looking at. Currently, I'm logged in as a student named I'm a Demo. And Zombie Line Defense is our flagship game. That was the first game in the suite, and this one covers graphing lines, plotting points, and things like that. So, Zombie Line Defense, there's some little cover art for the game, and this is the first little bit of the game. So far I've destroyed 0 zombies, so I'm not doing very well. My little guy in the middle there at the origin is frustrated, and you can see at the top left all the different kind of tools that I could use to try to destroy zombies. It is a turn-based game, so I get to try to fire a weapon, and then all the zombies move 1 unit towards me. So for instance, I could drop a bomb. If I dropped a bomb here at 2-4, the zombie at that place is getting vaporized. And with some more powerful tools, I can shoot horizontal lines or vertical lines. And there you can see I'm killing more than 1 zombie at a time. And then we get into the more advanced stuff. This is where, through usability testing and iterative design, I know that this is the first level, level 5, where students really start to struggle. You're putting in the slope and the y-intercept to try to graph a line, and that line will kill anything in its path. Here are inequalities as well, so this is wiping out an entire side of the coordinate plane. So you don't get very many of those in the game, but they are pretty powerful when you get them. And eventually you die in this game. It's like Pac-Man. You go as far as you can and eventually you die. But in this game and in all games in the suite, you get a number of stars for how well you did. So if you kill at least 150 zombies, you get a star. If you get 200 zombies, 2 stars. If you get 250 or more zombies, you get the full 3 stars. And every game has a way of earning these stars. Now back to the platform, we have my progress. And on my progress, I can see how well I've done. I can see, okay, in that Zombie Line Defense game, this was from a previous play, because I've earned 3 stars, and I've killed 273 zombies in level 8, which is the final level of the game. And I can basically just see stats for how I did. Now we're looking at the same platform, but there's some more menu items on the left because I'm logged in as a teacher. And the biggest thing here is I have my own dashboard. And the dashboard lets me manage my students, manage my classes, and see how they're doing. So here we're looking at the game performance on Zombie Line Defense for all of my students. And I can see that I'm a Demo does have 273 zombies killed. They've had 15 game sessions with this game. And I can just see how they're doing on that game. And now it's showing the overall performance, meaning not just in one game, but it's showing all the different games and how many stars they got on each game. So for I'm a Demo, I can see, yep, they've got 3 stars on Zombie Line Defense. They've gotten 1 star on False Floors. With Jello Monster and Song of Cibola, they've played the game, but not well enough to earn a star yet. And then there's 1 game that's unplayed so far. Now, in the platform, there are learning resources. These are videos and other learning resources that kind of help a player or a student prepare to play the game or to go back to when needed. These are the resources for Zombie Line Defense. And you can see that there's a video there for preparing for level 1 and 2. There's another resource for preparing for level 3 and 4, and so on. So every game has their own set of learning resources. And these are also available to students. So both teachers and students can see the learning resources. But there are also teaching resources. And these are only available to teachers. So, debriefing, worksheets, anything that might help the teacher kind of present to the students or prepare for the lesson. Could be a lesson plan. And one thing that's very important in game-based learning is debriefing. So I try to include debriefing resources with each game that I make. This is one of the ways that teachers can ensure that students are learning what they need to be learning and not unintentionally learning things. Through gameplay, they may get some misconceptions about the right way of doing something because they're following some way of doing it that worked in the game, but doesn't necessarily always work. And so this is one of those opportunities to correct that misconception. Now, for a lot of the work I do, it's funded by research grant money, just funding from outside sources. And for this project, I have not secured any funding. So all of this stuff I've done on my own, some collaborators here and there, but with no funding. But I do plan to launch a crowdfunding campaign on Kickstarter, which is supposed to launch January 6th. And I'm hoping to raise some money for this project through that. If you're interested, you can search for Paizo Math on Kickstarter. The next example I want to give of serious games and my research and practice is Mazer. This is another game that is focused on using the game itself to promote learning, in this case language learning. And Mazer is a game that was inspired by, when I was a kid, just loving to make mazes. I had graph paper just like this and I would create tons of mazes. My mazes were not this simple though. I would add portals that when you went through the portal, you'd flip over the page and you'd be on the other side of the page, still in a maze, and you could flip back and forth and you kind of have to remember what's on one side of the paper to go through the correct portal on the other side of the paper. But it was more complicated than that as well. I didn't just go through the paper. I had to be really careful because if I went through in the wrong spot, I might find the treasure, but I also might get eaten by a monster or fall in a pit of spikes. So that was kind of my thing for a while when I was a kid. And recently I showed this to my 6-year-old son and we made some together and it was fun and he had a blast. And we even showed it to a neighborhood kid and they were totally into it and started making their own. So I could just see that this was fun for kids. And of course, everybody knows that mazes are fun for kids because they're on every single restaurant kids menu you ever see. So kids like it. And, my son is learning to read. And so it all came together with this game called Mazer. But at first it wasn't a serious game. It was just me and Josh Emswiller, who's an artist, also works for VSGI and is the MGTA director. MGTA is the Mason Game and Technology Academy, where we teach mostly high school kids, but people of all ages about game design and various things. So here is a little example of the game. When I click, I can click around to move, or I can use my arrow keys to move. Got a little pop-up dialog. You can see the portals working there. The father went through the portal. It's currently on a cutscene. Okay, now I'm able to move again, and I'm walk around. I'm going to start using my arrow keys here, and I go to the other side of the world, and I can try to get through. I'm trying to get to find Mama, apparently. So I can't get to her directly, but if I can get to that portal up there, I'll be in the right room. And I do have bombs I can get. So what can I do with a bomb? I can blast between walls. And this is a very early version of the game. I even have a Zelda-like movement system from one area of the maze to the next. And that was back in 2024. A more recent demo version is after we started working with Ian O'Brien. Ian O'Brien is an assistant professor of literacy education from the College of Charleston, and we recruited Ian to kind of work on the project with us after we decided to make the purpose of the game focused on literacy. Here's a demo of that right now. So the person's arriving home. This is a cutscene. Just broke out of the cutscene, and I'm able to move around again. And when I get close to somebody, the cutscene begins. So I can't move at this moment while the cutscene's going. I'm clicking for the text to keep going through. There's my new portal going through the door. And I'm inside the room. I can see the Mama. Still have to get to her. This is an early level, so I don't need to be using bombs to get to her, and there's not very many portals at this point. Fast forwarding here to get to the Mama. And so there's definitely reading going on. And once I finish that first level, I can see other levels. I call them episodes. So now we're on second episode. And in this one, you start collecting letter blocks. And so the first three letters is the name of the player, J, and they can start collecting those. And so that was just a quick preview of the game in its early development phase. The project is currently shelved at the moment because we're all kind of busy folks and we haven't got funding for this one yet. So it's one of those that may stay shelved for a while unless some funding comes in, we write a good grant, and if we get that, we're going to start the iterative design process to start making this game really fun. The third example of learning through gameplay is this project I worked on that was funded for learning MySQL. MySQL is a language for interacting with a database. And so it's querying databases to get information. And so we made a murder mystery game that was used in university computer science classes where the players would try to solve a mystery by querying various databases. This was a project supported by 4VA, and I worked with Dr. Sharif Abdulhamid from Virginia Military Institute and one of his colleagues to make the game for his students. And we hired some of our own George Mason University students, Shweta Annapurna and Ajay Dike. They were grad students from computer science, and they built this game out. You can see here in the screenshot that we're selecting everything from the crime report and getting those results, 13 pages of results. And we are trying to basically get clues to solve the mystery. That project is complete. We presented a paper and wrote a paper and presented it at Frontiers in Education Conference back in 2024. Another example of learning through gameplay that is a project that we're working on right now, which is also supported by a 4VA grant, is a collaboration with our nursing faculty, creating an escape room type game, which the instructors will be using in their classroom in little short segments, so 20-minute kind of gameplay sessions. I worked with Yanika from GMU and some other faculty members from VCU and UVA. We also hired students for this project. These were game design majors. The programmer was Alex James, who was a recent graduate, and the artist was Alex Scrivener, who is currently a senior in the program. And here are some screenshots. They're pretty early on prototypes because we've only been working on it since the beginning of this semester, but we've had a lot of good progress, and the game should be complete by the end of the semester, and it will be implemented next semester along with conducting the research which uses the game. Okay, so with those examples out of the way, I want to talk a little bit about using game development for learning, for interdisciplinary learning. We already do that with VSGI, with the Mason Game and Technology Academy. Students come from all over the United States to GMU to take courses and learn about game design, typically in a 1-week, 40-hour session. And they mix art and animation and programming and producing and design, all these things, very interdisciplinary approach. But in this example that I'm going to show, it's really focusing on mathematics and what kind of mathematics do you use when you're developing games. And there's a lot of research that shows this is an effective way to teach math, is to make sure that you're placing it in a real-world context. So this real-world context is game development, and why would you actually be using some of these math concepts? This is a book that I published in 2024. It's not all mathematics of game development, it's just a collection of applied lessons. And each chapter in the book has an introduction, a math section, then how do you apply that math to game development, so some demo, and then some challenges, trying to get the reader to say, hey, how can I push this a little further? Then there's kind of a review of what they've learned in that chapter called achievements, and then some exercises, just like in a regular math textbook. So with 10 different chapters, there are 9 projects included with the book, but you can also see from the chapter titles the topics in mathematics that are covered in the book. And so kind of jumping down to the chapter 4 and 5, you start seeing right triangles, Pythagorean theorem, distance formula, finding angles, using trigonometry there in chapter 5. In chapter 6, we really get into something used a lot in game dev, which are vectors. And then chapter 7 is kind of sine and cosine, understanding those kind of waves and how you can modify them. But then back with chapter 8 and 9 and 10, those are all vector mathematics again. When do you use the dot product and how can you use it, the cross product? So they get into pretty advanced math concepts here, but the whole book is written for entry-level programmers. So the programming, there's a lot of learning of programming in the book too, but you shouldn't have to have previous experience with it. You're writing code within a game engine, within the Unity game engine. And the math is not in one particular domain. You can see there I was talking about algebra, linear algebra, trigonometry, vectors are Calc 3. So I don't think that teaching within a particular domain is always the most effective when it comes to mathematics. That's not how it's applied in the real world. And so I think it's good for students to see that, yeah, these kind of go in and out from different domains of mathematics within the field, and that's normal. So I'm going to kind of focus on one chapter here, the chapter that introduces vectors. And vector is, of course, from Despicable Me. His little quote here really gets down to what is a vector, something that has both direction and magnitude. That's what defines a vector. And then it gets down to the point where you start using vectors, and you have to know how to add vectors, how to subtract vectors, how to multiply, scalar multiplication, vector multiplication, all of these things, how to normalize a vector. And I'm not teaching that in this presentation, but when you know how to do all of those things, you can combine them and make things happen. So in this case, if an enemy detects the player, how do you get the enemy to chase the player? Well, you can increase their speed. That's a scalar. That's pretty easy. Just increase a number. Then you get the vector from the enemy to the player. And you learn through this chapter that that's just as simple as vector subtraction, which is a pretty easy calculation. Then you get the directional vector from the enemy to the player. So that means, well, what's the directional vector? It's the same vector as the vector that is pointing from the enemy to the player, but it's normalized, meaning it has a length of 1. So that's a directional vector. Then you multiply that directional vector by the speed. So then you first shrink it down to size 1, and then you multiply it to make it grow to the correct length for its speed. And then you can multiply it by time.delta time. That's more of a programming thing to adjust for frame rate, but it is still scalar multiplication. And then the last step is to say, hey, let's go ahead and move this enemy towards the player, which is just adding that new vector that we just figured out to the current position vector of the enemy. So, what does that look like in code? Well, many of these steps are kind of combined into that one line of code there. And again, I'm not teaching coding in this presentation, but you can just kind of see and get the feel for how are we applying these mathematical concepts to our coding. A more advanced thing, a later chapter, they talk about cross product. So if you take two vectors, A and B, and you want to find their cross product, it is basically a perpendicular to the other two vectors. So A cross B is a perpendicular vector to A, and it's a perpendicular vector to B. And there's a formula for it, and there's a proof on how that formula came to be, and that's all in the math section of the book. But why would we use cross product in game development? And that's what the whole book is about. It's saying, hey, here's the math, and here's why you would care about using it. And so here's a little example. We have the camera facing two characters in the game, and you can see the view of the camera on the bottom left there. And if those players move around, the camera will need to adjust for them. And it needs to kind of follow them, keep them both inside in view and not too far away, and spin around them if they change positions, things like that. So how do we do that? Well, here's a little bit of preview of the math. If P1 is player 1 and P2 is player 2, then you can get the vector between them. That's the green line. You can also get the midpoint on that line, and then you can get the vector from that midpoint to the camera. So that's kind of that's the red line there. And we can adjust, or basically we can figure out where that camera is going to be by going through these kind of phases. And this is what the script looks like. Again, we're not going to go through it a lot here, but you can see like on line 15, we're getting a midpoint. On line 17, we're getting the vector between the players through subtracting their positions. Line 18, I could show this mathematically, but I just used the cross method of the vector3 class to get the cross product, which gives us that other vector, and then I apply it, right? And then the last line there, 21, is just, hey, make sure the camera is looking in the right direction, looking at that midpoint. But again, not teaching coding here, just showing that this is a great way to teach mathematics. And it might seem like, oh wow, that was overwhelming. But remember, this is the 10th chapter, I think, of a 10-chapter book. It builds up to this, and it gradually brings the learner to understanding all of this. So some things that were not discussed in this presentation. We did not discuss gamification. It's a very worthwhile topic. And that's why I'm bringing it up here, but we didn't discuss it in this. We talked more about serious games that are fully games. They're not just gamifying some other thing. We did not talk about other serious games, things that are not just about learning. Serious games can be about improving your health, creating change, having a social impact. Anything that's primary purpose is not entertainment, that could be a serious game if there's some other purpose for playing the game. And then other research projects that VSGI is involved with, that I'm involved with, which I didn't feel were as pertinent to this presentation, but just as a call out to say, hey, we are doing these other things. One that could have been in this presentation is the VR crime scene. the virtual reality crime scene project, in which we work with forensics faculty to create a crime scene that has to be processed. And even though we're at the prototype phase right now, eventually that might be a bigger project that is used within classrooms. We also have a virtual reality gait, which is like the way people walk. It's about researching how people walk when they have high anxiety. And so we do things that are not about learning, but they are about extending knowledge. That's why we do research, is to say, hey, we need to know more about this topic. Okay, some takeaways that I hope you got from the presentation are that well-designed gameplay can promote learning in any domain. We work with people all over the university in all kinds of fields to apply gaming or gaming technology for their needs. And game development can promote applied interdisciplinary learning. Lastly, the VSGI is always looking for interesting research opportunities and passionate collaborators, and that's myself included. I'm always looking for some interesting projects, and really, even more so, looking for people who are good to work with. So thanks for joining, and I hope you enjoyed it.